So I'll talk about DuckPGQ, which is implementation of SQL PGQ in DuckDB. I'm a PhD student at the CWI Database Architectures Group, supervised by Peter Bonks, who some of you might know, I guess. Right, graph data management. Right. So in this case, we talk about highly connected data. There's a lot of many-to-many relationships. And in many cases, already tables can be used to represent these graphs. So in this case, we have so-called vertex tables and edge tables, but they might not be explicitly defined as a property graph or thought of as a property graph, but they for sure can represent one. And then there have been some survey papers on what people do over these graphs, graph exploration. And that's mainly three things. One is pattern matching, which is finding a pattern in your data. Another one is path finding, so finding the shortest path, for instance, between any two nodes in your graph. And finally, we still have the relational operators, so the aggregations, the filters, the joins. So those are the three main components. All right, so the property graph, we use the property graph model here, which I don't think I need to explain. And storing that is perfectly, you can perfectly do that in SQL already. Here I define the following schema to have the property graph on the right. I don't define foreign keys, primary key, foreign key relationships, but you can in DuckDB. All right, so storing the graph is not a problem. But now the query language, I would say, is the main problem here. So we have given the following prompt: count the number of people that Bob indirectly follows who live in the city Utrecht, which is a city in the Netherlands. Very nice to visit. And it's a bit of a jump scare query, but in SQL 99.9, you had to use this with recursive statement, which I think to most people is not easy to write, not easy to read. And from a systems perspective, these are also not the most performant queries out there. So yeah, we have this with recursive, where we recursively go over the paths. And we have to keep track of the lists ourselves with an array. So then also your system needs to support arrays, which not every system does. But maybe nowadays it's better. All right, so in SQL PGQ, the first step is to create a property graph. We heard Oscar talk about this already. And for the property graph I showcased earlier, we would define the following property graph. And in this case, in DuckPGQ, similar to what Oracle does, you don't need to specify the label. If you don't specify it, it defaults to the table name. You can also omit the properties, which are the columns, basically. In that case, you allow all columns to be selected. And if I would have defined primary key, foreign key relationships, I wouldn't need to repeat them here. The source key referencing the person ID. But I did not earlier, so I have to do it here. All right, so now we have created our property graph. And now we have the same query. And in SQL PGQ, the query is this, where there's this match statement. And importantly, this indirectly follows is represented as this cleany star to say there's 0 or many hops between the person 1 and the person 2. I could have also used the plus to say there's at least 1 hop, but no upper limit defined. And also Oscar mentioned this, the cleany star could potentially lead to infinite results or non-terminating. So I have to define this any shortest. Yeah, I don't have infinite results. All right, then there's this columns where we project this P2 ID column. And then outside of the match statement, we can do an aggregation to count the number of IDs or people. So if we look at the two queries, the plain SQL and the SQL PGQ, the SQL PGQ query is about 4 times more concise, and the purple parts highlight the pathfinding part of the queries, and the green part is the aggregation that didn't change, And the pattern matching also didn't change that much in terms of conciseness, but maybe it's a bit easier to see or to read as a user what this query does. Most certainly that's the case for the path finding, I would say, but personal preference maybe. So yeah, if we look back at the three components, the pattern matching, the path finding with the cleany star, DuckPGQ also allows the upper limit and lower limit to be set. And then there's still the relational operator, so your filters and your aggregations. All right, so there's been a couple of implementations in relational systems that I know of. So Oracle mentioned earlier, DuckDB, and recently Google announced support with Spanner. They say they support GQL, but I think it's like mostly SQL PGQ. Actually, it's part of the Google SQL, which is the Zeta SQL repository on GitHub. So Google SQL is shared among all systems at Google, so there can also be support for BigQuery or any other internal system F1 in the future. And there's one in progress. I'm not sure about the status of it at the moment, but there's Postgres support maybe coming as well by Peter Eisentraut. This is something he sent in the Postgres thing. But we'll have to see how support goes there. So yeah, now I'll talk a bit about the implementation of SQL PGQ in DuckDB. And I won't go into too much implementation detail, but yeah. So DuckDB is originally created at CWI Database Architectures Group by Hannes Mühleisen and Mark Rasveld. And their initial idea was to target data scientists because they were wondering, why don't data scientists like to use relational databases? Well, most found it hard to work with, difficult to set up, or yeah, not very performant maybe. So they created an analytical SQL system that is easy to link in as a library and really focuses on this analytical support. So it runs easily on your laptop. It's really easy to install, etc. It has a zero-copy data frame access, and it's took off quite a bit. So there's an active Discord blog. They have events. By now they have reached, I think they just reached 25,000 GitHub stars and more than 10 million downloads. And there's a spin-off and VC company behind it. And so they first focused on data scientists, but they have since branched out a bit. So this is them trying to run TPCH 100, scale factor 100, on a new iPhone 16, I think it was. The problem was it got a bit hot, the iPhone, so they had to cool it with some dry ice to keep it cool. But I think it was quite successful, this experiment. But yeah, it can run anywhere, on your laptop, on your mobile phone, on some satellite, whatever. It's being used quite a lot. And the core idea, this analogy is a bit of the, yeah, they compare it to a hamburger. In research, we've focused a lot on the hamburger itself, the meat, which is the performance. And we really try to optimize for the performance. But as a user, you want more than just the good beef. You want the whole package, which is the user experience. So yeah, like I said, it's very easy to install. There's no dependencies. It can run anywhere. You can query data frames directly, zero-copy integration with pandas or polars, numpy, etc. And it has a very friendly SQL syntax. So you can, for instance, omit the select star if you just want to select all, you can omit it. And there's a lot of this nice SQL syntax quirks. And this is just from last week. They had almost 2 million downloads on Python alone. And in the last month, 8 million. And this is just for Python. So there's also other ways you can use DuckDB. But this is publicly available data. One of the key features I want to highlight of DuckDB is their support for extensions. So their core idea is to keep the core of DuckDB relatively small and then allow users to add extensions depending on their use case. So there's a spatial extension, there's a Parquet reader if you want it, there's Postgres and SQLite scanners if you have data in your Postgres database or SQLite database. And these are also really easy to install and load. And this allows the core of DuckDB to remain relatively small, easy to load on any system. But yeah, you can tune it however you want. So that brings me to the DuckPGQ extension. It's open source. The last version I released is 0.2.0, which adds support for creating a property graph over an attached database. So for instance, if you have a data in your Postgres or your SQLite databases, you can create a property graph over that in DuckDB and query those databases as well. So technically, there's no support for Postgres or for PGQ in Postgres and SQLite, but through DuckDB. And it's installable as a community extension. So before you could only load them through an S3 bucket, and it was kind of hacky. But now they allow for community extensions, which are third-party extensions. Sure. Okay. And yeah, so if you start up your DuckDB instance, it's as easy as saying install DuckPGQ from community and load DuckPGQ, and you're good to go. And this is starting to take off. As of starting from 1st of October, this is a very new thing, this community extension. But as of the 1st of October, they are starting to release also the download data. So in total, it has been downloaded 15,000 times, this community extension. And just last week, I reached a new peak of 3,100 times in a week, which is the second most popular community extension at the moment. And it's a lot more than I expected, to be honest. I thought it was more of a research project that some people used, but apparently it's getting used quite a bit. And I haven't received 3,100 bug reports, so I'm good on that part as well. Sorry, the DuckPGQ, our parser is the DuckDB SQL, and then the PGQ part. So it's like a superset of those two. And we hook that in using the parser extension that DuckDB provides. And then our main way of dealing with the PGQ queries is to translate them to a standard relational query plan. And this allows us to use the DuckDB query engine while still providing the PGQ syntax. And only for pathfinding, those cleany star queries, we do special UDFs to do that, and we create a compressed sparse row data structure on the fly to query over as like an indexing index. And I won't go into detail here, but there is another talk I did at the TUC meeting a couple of years ago. It's basically still the same way. I'm working on a new implementation, but I haven't released that yet. And apart from the PGQ part, I want this to be a broader graph analytics community extension. So I also support the PageRank, weakly connected component, and local clustering coefficient algorithms. And I plan to introduce more in the future as well. In terms of performance, I did a micro benchmark of the LSQB using the LSQB micro benchmark, which is a mix of cyclic and acyclic queries. Gabor mentioned this one early in the day. And I used DuckDB, Kuzu, and Neo4j, which are the DuckDB is the yellow line, Kuzu is the green line, and Neo4j is the blue line. There's 9 queries in total, and there's 3 scale factors, 1 to 10. And consistently, you see across the board that DuckDB is the fastest performing out of the 3 systems, except for query 6. There, Kuzu is actually faster. So I'll look into that, why that's the case. And no, it's, I mean, Kuzu is also a really good system, and yeah, looking forward to what they get in the future. So yeah, that's in terms of performance. So yeah, this approach really allows us to use the DuckDB query engine, which is quite performant, while not having to put my effort into improving that necessarily. So I want to highlight a couple of things that we do, or that I want to do at least, that go beyond the SQL PGQ specifications. I don't know the specification by heart, so if I miss something, then apologies. One thing is that we support inheritance. And this is a toy example on the right here. We see the table organization, which has two types, university or company. And we support inheritance through using a bit mask column. So this bit mask is a 64-bit integer column that currently users have to specify themselves or create themselves, but maybe I'll make this some sort of hidden column at some point. And that's this type mask column. So for universities, the first bit is set, and then for companies, the second bit is set. And then you can create a property graph over this, where you create it over the table organization, and you define the column that is the type mask, and the sublabels that correspond. And then in your match statement, you can simply say, I want the organization or the company or the university, and I add a filter underneath to filter on this type mask column. And filtering on this type mask is, first of all, we don't need to filter on strings, which are way slower. We can filter on a integer column instead. And I don't support this yet, but I want to in the future support bit operations. So in this case, we only have 2 sublabels, but you can imagine you have more in your system. So I want to have either company or university, or not company, etc. That's something I want to add support for in the future, but for now, that's not supported yet. I won't probably allow a union of 2 different tables anytime soon, but maybe if someone asks support for it or sends in a PR, I'm happy to look at it. And then finally, some extension of the cheapest path. And this is actually marked as a language opportunity in the specs. So by default, the edge weight is only 1. But our parser actually allows you to specify a cost of the edge weight, which could be some special column. In this case, the amount of the transaction, for instance. And then you could do cheapest path over that instead of shortest path. And that's something I want to support also in the future, but I haven't gotten around to supporting this yet. All right, so if you want to try it out, it's as easy as starting up DuckDB in your favorite environment and saying install DuckPGQ from community and load DuckPGQ, and you're good to go. And there's actually a QR code, which I'll very subtly unhide. And yeah, to conclude, introduce DuckPGQ, enabling SQL PGQ queries with DuckDB. I've shown that it can outperform Neo4j and Kuzu for analytical pattern matching and possibilities to extend the SQL PGQ specification. And with that, thank you for your attention.
Oh, thank you very much, Daniel. Any questions?
All right. So my first question is, which came up yesterday at Connected Data London a lot, is the problem of unioning multiple tables. What's the problem of just simply having a union of university and company and just running the query on that? Why do we need the bit masks?
The bit masks, so you technically wouldn't need them. You can, for instance, also filter on the type here, the type column. But then you have to filter, for instance, on a string. And we think this type mask would just be faster. The problem with unioning on 2 different tables is the columns might not match, or it gets very complex with. We also use the row ID for the pathfinding. And if you have 2 different tables, the row ID is a dense ID from 0 to the number of rows in the table. And then the row ID is all of a sudden not unique anymore, and yeah, that's problematic. So yeah.
Okay, thanks. And my other question is, you showed the benchmark results for DuckDB 111. Is it with the custom joins that you put in, or is it vanilla DuckDB?
This is vanilla DuckDB. I think so. The join operator got changed slightly in DuckDB, or quite substantially in DuckDB 1.1.0 by a master student of ours, which made it a bit faster. But this is no special algorithm or anything just yet.
So these are binary joins and not factorized.
Yeah, yeah.
Thanks.
Cool, thank you. Wonderful.
Do you support all of the SQL PGQ DDL? I mean, can you support, multiple labels? Can you do horizontal partitioning in terms of the unions that make up the edge tables and the vertex tables, or is it simplified?
I didn't understand the second part of the.
Well, I mean, I could
Yes.
create a union of as long as it's union compatible, I could have something coming out of table A, something coming out of table B, something coming out of table C, and then they'll all be put together into a node table, right? So I've got 3 different underlying tables, right, in the SQL tables in the source. You don't handle that?
No. Every label has to map to a unique table. So
right. And that unique table has to be an underlying base table.
Yeah, a base
SQL,
table at the moment.
Which is that was my second question, was relating to the viewpoint. I didn't understand why you thought it would be difficult to sit on top of a view.
Yeah, I at some point I looked into this, and maybe I didn't look into it enough, but I couldn't immediately figure out the schema, which is very implementation specific, but I couldn't figure out the schema of the view.
Oh, I see.
So
in the actual DuckDB implementation.
So I was hesitant to add support for adding views to your property graph. Maybe for a materialized view it could work, but at the moment I just support base tables to create a property graph over your base table.
Because I mean, I've always thought that. I mean, it's a read-only system, so you haven't got the complexity of view updates, and I've never really understood why we ended up in SQL PGQ with all of this ability to specify the composition of a table when you could do that all at the SQL view level, so and then you'd be back to your situation where you're saying, I've got one underlying table, but it's actually a view, and any amount of complexity can happen inside that view. So I think the standard lets you do too much.
I think
and it should be passed back to SQL, pushed away.
It's also why I if I go back to the creation, like there's the ability to specify the properties that your property graph can handle, which is like a subset of the columns of one table. DuckPGQ supports all of that, but like I would rather users just allow all columns to be used in the table.
Right, and if you had a view, then you can do the restriction in the view, and then none of this exists, right?
So,
and I think they came to this conclusion in, I was sort of Kwan Cicada about the analogous thing in RDF, and I can't remember what the standard's called that lets you map from SQL tables into an RDF graph, and they have the same. He said, effectively, you end up with, why don't you just do it all in, get everything sorted out in the SQL view, and then your mapping is sort of one-to-one. It's very straightforward. But I think this it seems to me that some of the things you were talking about, the implementation difficulties with the multiple labels and so forth, are sort of capable of being handled at a system level. You can sort of push this out of sight and get the syntax nice and clean above.
For sure, there's more possibilities in the implementation level. It's just I have limited time to what I support.
When are you forming the company around this?
Maybe at some
then you
point.
won't have so much limited. Well, you'll have a different kind of limited time.
Maybe at some point, but if there's enough interest.
On a final point of help on this, is there any particular process for people to open PRs, or just like throw issues at you, throw PRs?
There's a GitHub, the DuckPGQ extension. Also, if they go to If they go to the QR code, the community page of the DuckPGQ, here, there's a link to the GitHub where they can create issues or they can build a project or they can play with it. Yeah.
Wonderful. Any questions from online before we finish up?